Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad dan HAIKAL bin Muhammad RAZALI. My magic number is D0920100084. I am from Group 2. Today with Group 2 will represent about the assignment that I given. And this is our group member. Okay, next I will continue with the objective for the experiment. To understand the mechanism that used it to launch the ping-pong ball. And next, to determine the relationship of the projectile motion with the dynamic and mechanical motion subject. Next, for the introduction, the projectile motion will indicate the motion of object after it being projected into the air. As we all know that the movement of the object is called as the motion, meanwhile the path that the object go is called trajectory. The projectile motion will only occur if there are any force applied on the object at the beginning of the experiment. The force that already applied on the ball will undergo the law of conservation energy, where the energy will be converted into another form because the energy neither be created or be destroyed.
Assalamualaikum and hi, my name is IZZAT NAJMI with matrix number B0920010065. I will talk about the mechanism and relation. The projectile motion experiment from our lab session, in which we had to shoot a steel ball using a miniature launcher, served as the inspiration for the primary idea. The design and mechanism have been devised in our own way. In the lab session, the spring is compressed to function as elastic potential energy while the rubber band is pulled by using the chopstick to produce them. So first, the cutting board will act as a base for our ping-pong ball launcher prototype. The cutting board is wide and flat as it can hold the prototype. Next, the transparent plastic bottle, where we decide to use it as it was strong enough for this challenge. After that, we have rubber band that will produce elastic potential energy when it being pulled. And the next one is the chopstick that used to build the structure to hold the plastic bottle and also as the device to pull the rubber band. Furthermore, we use a sharp cutter to create two horizontal holes on the plastic bottle. A hot glue gun was used to attach and make the structure stronger. And finally, the ping pong ball that will be projected. So here is the ping pong ball launcher prototype. After we measure the height of the launcher to the ground, which is 6.1 cm, we obtain the angle to project the ping pong ball, which is 28 degrees.
Assalamualaikum and hi, my name is RAZALI. Now I'm going to show the conclusion on how to achieve the desired target from starting point to end point. Alright, the idea is we need to find the initial velocity and time of flight so that we can determine the elevation required. For the first step, we assume force applied is 2.7 Newton and mass of ping-pong ball is 0.0027 kg. Then Hmat that we get after launch the ping-pong ball is 0.24 meter. Okay, we use this equation to get the V0, which is initial velocity in terms of t. Then to find t, which is time of flight, we use this equation. After that, we need to substitute equation 2 into equation 1 to get the initial velocity. Next, we need to find k value, which is spring constant of the rubber band. This is because we need the k value to substitute into the conservation energy equation. And finally, we can get the required elevation, which is 2.21 cm. Alright, that's all for me. Thank you.
My matrix number is D0920100047. For this assignment, we need to launch the ping-pong ball from point A to point B by applying the projectile motion equation. Projectile motion is where position, velocity and acceleration of a particle as you move along a curved line in 2 or 3 dimensions. For the first part, we need to calculate the velocity and time for the ping-pong ball got into the hole. That's why we're using the projectile motion equation. X equal to Vx times t and y equal to Vy times t minus 1 over 2 times g times t squared. Next, we are using the principle of conservation energy to find the elevation, which is V1 equal to T1, whereas the V1 equal to V elevation times 1 over 2 times kx squared plus V gravity times mgh and T1 equal to 1 over 2 mv squared. After that, we plot a graph of force versus elongation to find the rubber constant by calculating its gradient. The force is obtained by hanging width before launching the ping-pong ball of an elongation obtained by measuring the extension of the rubber band.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAKIMI bin AZHAR. My matrix number is D0920100418. So we continue the conclusion. In conclusion, we can conclude that the ping-pong ball can launch 1.5 meter away by using the concept of projectile motion. Before the experiment, we used a launcher and the ping-pong ball to launch the ping-pong ball into some distance that around 1.5 meter to gain the data and achieve the theoretical conclusion details. That's all for me. Thank you.